right, good morning, everyone. My name is Kevin Griffin, and welcome. Got my coffee ready to go. Welcome to this is day 3 of Advent of Code. I've been working through these exercises for the past 2 days, and I thought it'd be fun to record and kind of talk through my process. So if you're new to software development, or you're getting into exercises like Advent of Code on your own, maybe you could learn something from my process, or you could just see me fail miserably. I am on day 3, so I'm going to go to adventofcode.com, click on day 3, and we're going to talk through the problem. And then we're going to set up our project and try to answer part 1. If you've never done Advent of Code before, the way it basically works is you get the problem and you have part 1, which is usually a simple solution, and then you have part 2, and part 2 is a little bit more of a complex solution, but it's based off of whatever you built in part 1. So day 1 was all right, day 2 was a little bit easier, day 3 we'll find out. So day 3, binary diagnostic. The submarine has been making some odd creaking noises, so you ask it to produce a diagnostic report just in case. So day 1, day 2 are focusing around this idea of a submarine. So this is kind of the theme that they're going with this year. The diagnostic report, your puzzle input, consists of a list of binary numbers which, when decoded properly, can tell you many useful things about the condition of the submarine. The first parameter to check is the power consumption. You need to use the binary numbers in the diagnostic report to generate 2 new binary numbers called the gamma rate and the epsilon rate. The power consumption can then be found by multiplying the gamma rate by the epsilon rate. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all the numbers in the diagnostic report. So they give us some example input. So actually, before we jump any farther, let's go ahead and set up our project. So I'm using .NET Core. So I'm just going to call this day 3. 1. And we'll open that in VS Code. Oops. Crap. I put it in the wrong folder. All right. It's all right. I thought I was already in the right folder, but I was not. So let's go ahead and recreate it. Oh, well. And we'll go ahead and jump into this project. I'm going to create a new file. I'll call it input.txt. For all the friends playing the home game, I'm going to bump up the font a little. There we go. And we need to put our input in here so we can safely go to our view and drop in our values. So we have some binary input. We have our program CS, which the first thing I do is I go get all the lines from the file. So we'll get input.txt. Oh, so GitHub Copilot is trying to help me. If you're not in the GitHub Copilot beta, you should totally get in there because it's very helpful in a lot of cases. So read all lines text. Let's get all the input. We'll do something with it in a moment. Let's go back and read. Consider the first bit of each number. There are 5 0 bits and 7 1 bits. Consider the first. Okay. Since the most common bit is 1, the first bit of the gamma rate is 1. All right, hold up a second. So maybe I'm misreading this. So consider the first bit of each number. Oh, the first bit. Okay, so I see what you're saying. The first bit of each. All right. The most common bit is 1. The first bit of the gamma rate is 1. The second most common bit of the numbers in the diagnostic report is 0. So the second bit of the gamma rate is 0. Okay. The most common value of the third, fourth, and fifth bits are 1, 1, and 0, respectively. So the final 3 bits of the gamma rate are 1, 1, 0. Okay, so I was looking at this wrong. Look at the numbers. They're saying, all right, well, this is the first bit of each number. So 1, 2, 3, 4, 5, 6, 7. All right, 7 ones. So technically, if you're looking at this in binary, this would be the first position. That's kind of a weird runoff. All right, I get it. All right. So you have to figure out the gamma rate, which is basically what's the more significant bit of all the numbers. Okay, then you have to calculate the epsilon rate in a similar way. Rather than the most used common bit, the least common bit from each position is used. So the epsilon rate is 01001 or 9 in decimal. Consuming the gamma rate 22 by the epsilon rate 9 produces power consumption 198. Use the binary numbers in your diagnostic report to calculate the gamma rate and epsilon rate, then multiply them together. What is your power consumption of the submarine? Okay, so they tell us how to convert this sample into their expected answer, 98. We use this to kind of test our thought process. All right, so first thing we have to figure out is the gamma rate, and then we can figure out the epsilon rate. So let's go back to our code. So gamma rate. I'm not even sure what gamma rate's going to be yet. And then epsilon rate. Did I spell epsilon right? I don't know. Doesn't matter. Nope, I did not. All right. Let's fix it. Oop, copy and paste did not work. Okay, so we need to figure out gamma rate first. We know that we have currently in memory a list of strings, and we need to figure out basically the first, the second, the third, the fourth, the fifth position. Does this specifically say our input is going to be 5 character or 5 binary digits? I wonder what our sample input is going to be. So let's look at the sample input. Yeah, the sample input is more than 5. It's going to be more. So we need to be able to handle a case where we have n number of binary numbers. All right, let me knock that down a little bit. Okay, so this is the most common number or bit, and this is the least common bit. All right, so let's just say for each L in lines. Actually, we don't even have to do that. Let's just start with the first line. So first line is lines dot first. We'll use some fancy link here, and we'll actually iterate over each character in the line. So actually, I don't want to do that as a for each. I want to do that as a for loop. So we'll say in x is equal to 0, x is less than first line dot length. Yep. Technically, that's not what we want. All right, so the bit. That's right. So the first line is the character. So what we want is could use link. We can basically say, all right, so let's go to lines and let's count, and yeah, this is fun. We're going to read all text async. Oh, because I'm dumb. We'll change that to input, and then we'll say var lines is equal to input dot split. Basically, I want to split a new line, so there we go. All right, so that should give us all of our lines. Yep. So then we iterate over every line. We basically count zeros, and then we count ones. Okay, so then just for funsies, let's go ahead and iterate through the lines real fast. And we'll say, all right, so if count 0 is greater than 1, we'll add the string 0 to gamma rate. Yes. Yep. All right. Else gamma rate is 1. It doesn't really talk about what is there a case where they're equal. Unless they're giving us an input where that's just not going to be the case. So let's prepare for this. So if count 1s is greater than count 0, we'll add a 1 to the gamma rate. And then we'll do else console write line error bit is that's bits are equal. Yeah. Copilot knows what I'm trying to do. All right, so then for each one we're going to basically console write line L gamma rate, and then we'll also do epsilon rate. So G and then E. Okay, so oh wait, that's not where those go. All right, we'll spit out all the lines, and then we'll do console write line. Yeah, come on, Copilot. There you go. Let's run this. Oh. Okay, so why is epsilon not? Oh. Oh, because I'm not figuring out epsilon. So epsilon is the opposite, right? Okay. Did I save that? Okay. 1 0 0. All right. Is that right? The gamma rate is 1 0 1 1 0 1 0 1 1 0. Okay. The epsilon rate is 0 1 0 0 1. Okay, that's correct. That means when we're all done, basically power consumption is equal to gamma rate. I need to convert them into to integers. as int. All right, I don't remember how to convert binary. Crap. Hold on. This is why we have the Google, right? Just for sake, I'm going to Google this on the different. Convert binary to int. It's probably something simple too. Oh yeah. So Copilot had my back here. Copilot's like, I know how to do this, man. So we'll do epsilon. Epsilon as int. Okay. Epsilon rate. Gamma as int. Or epsilon as int. Okay. So assuming all that's correct, let's run this again. I like double check my work. All right, 22 or 9. Ones, twos, fours, 8. So 8 plus 1 is 9. Cool. All right. 8. So 16, 17, 18, 19, 20, 21. All right, 22. That's right. Okay. So power consumption is technically gamma as int times epsilon as int. So let's rerun this one more time. So 198, that is the number that is in the thing. Okay, cool. So we have the baseline. We can get the same answer as them. I'm technically going to rename this as sample. And I'm going to recreate a new file called input.txt. Save all that. Let's go back out to we'll do .NET run. All right. Assuming this is all correct, let's assume. Let's put the answer in. That's the right answer. 1 gold star from me. Finding the sleigh keys. Oh, that's right. It's the whole gist. Okay, so let's go to part 2. Boy. All right. Before we even get started here, I'm going to go take my project and I'm going to go up 1 and I'm going to .NET new, a new console app. Open that in VS Code. And then day 2 usually builds off of part 2 builds off of part 1. So I can take all this code, copy it over. I'm going to take the inputs and paste them in. Okay, so part 2 is ready to go. Now what they're going to do is they're going to confuse the heck out of us. And they're going to start with a slightly different problem. Oh my gosh, it's a big problem. Okay, so we're starting right here. Next, you should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. Both the oxygen generator rating and the CO2 scrubber ratings are values that can be found in your diagnostic report. Finding them is the tricky part. Both values are located using similar process and involves filtering out values until only one remains. Before searching for either rating value, start with the full list of binary numbers from your diagnostic report and consider just the first bit of those numbers. Then, all right, keep only numbers selected by the bit criteria for which the rating value for which you are searching. Discard numbers which do not match. Okay. If you only have one number left, stop. This is the rating value for which you are searching. Otherwise, repeat the process. Okay. To find the oxygen generator rating, determine the most common value, 0 or 1, in the current bit position, and only keep numbers with that bit in that position. If 0 and 1 are equally common, keep the values with 1 in the position. Okay. To find... Alright, so... Start with 12 numbers. Okay, so let's rerun this with our sample. Let's run this with sample instead. So this is going to give us some input. So let's put this side by side with... All right, all 12 numbers. All right, so we get through all of this, and we know that the most common is the gamma, and we know the least common is the epsilon. So if we go through all of these, okay, so the most common is 1. All right, so it's just going to leave, so we're basically going to pluck from the list. We're going to take the first one out, leaves the first one, the second one, the third one, fourth one, fifth one. So, all right, and so on. Okay, then consider the second bit of the 7 remaining numbers. So there are more 0 bits. So you dwindle that list down, then you do the 3rd position, 4th position, 5th position. All right. In the 5th position, there are equal number of 0 bits and 1 bits. So keep the number with a 1 in that position. As there's only 1 number left, stop. The oxygen generator rating is 1011 or 23 in decimal. Okay. Let's do that part first. Oxygen generator rating. Okay. So we have to do all this stuff basically to figure out this is gamma and epsilon. All right. Now we need to figure out power. What was it? Not power consumption. Oxygen generator rating. Okay, so we're going to go through. Let's create a clone of the lines. Sample. We'll call it line clone. So it's lines to list. Okay, that'll make a copy of it. So then what we'll do is we'll do for x equals 0. We'll go through all the lines and line count. So we know. Oh, get out of my head, Copilot. Wait, I don't need to do that. What I need to do is I need to go through all the positions in gamma. Is that what it said? Yep, because gamma are the most common. All right. So I want to remove from C. So line clone, these are all the lines to see where the CX is not equal to the gamma rate. All right, so Copilot's helping me here. Let's remove all the lines where the first position, second position, third position, whatever, is not equal to whatever that position is in the gamma rate. Okay. We need to do a test though. So if gamma hold up. All right. If gamma at x is equal, no. I'm getting thrown off on this fifth position. There are equal number of 0 bits and 1 bits. Keep the 1 with the 1 in it. Okay. Oh, so it's reiterating the entire list. Oh, so you got to recalculate the list every single time. All right, I was approaching this wrong. I thought we could just use the gammas, but you can't. You basically have to recalculate the gamma every single time with a different list of numbers. Okay. So, let's delete this. Technically, we don't need those. Let's get rid of those. Let's get rid of that. We can always rewrite that. Let's start from scratch again. All right, so we know basically how to figure out I'm going to rename this to let's take this. Let's make this a function. Might be a little bit easier. Call this public list. Actually, this will just return a string. Let's just do void for a moment. Process. This is going to take a list of string. We'll call it lines. It'll take all the lines. Is declared but never used. Yep, I know. Because what I have to do is I need to iterate through this list. So we'll process the lines. And this will get... okay. All right, I got this. So do process... No. Lines. Lines length is equal to 1. Break. Actually, I use do whiles very so we'll say while lines length is greater than 1 because we need to end with one number. Let's see. Oh, and this needs to be to list. To list. There we go. All right. Can I convert void? Yep, because this should be a list of string. But that's right. Let's just do count. Yeah. All right. So this needs to go through. Goes through the list, figures out the most common bit, the least common bit. Oh, I also need to track position. So then position, nope. There we go. Oh, you know what? This doesn't even need to be a do while. This could just be a for. So we'll say var x is equal to 0 while x is less than crap, we'll just say lines first length. No. Then what we'll do is we'll basically say, okay, well, let's start at position x. We'll pass in that position. Yep, I know. All right, so we're passing in the lines. Let's get the first line. When we get done here, we want to know position x and gamma. Nope. I don't need to know it as an integer yet. All right, so take, no. Oh, okay, reduced. So this is lines, select where, we just do where. We'll look at the line, so position is equal to the gamma rate position to list. Okay. So this should be if I'll run into this use case. Okay, this is where my use case will come in. Bits are equal. Keep the number with the 1. Okay. So gamma. All right. This is not necessary. Okay. Okay, so this will all right, let's write a method real fast. Just void write output that takes the list of lines. We write that's not necessary. Console write line. For each L in lines. That's console write line L. Yes. Okay. You know what? I'm going to pass the position in. So iteration X. There we go. Iteration. There we go. Okay. Let's see what we got so far. We haven't run code in a while. So let's clear. We'll do .NET run. Oop, I got some, silly build errors. Oh, so then this needs to return reduced. Build errors, more build errors. What build errors? There ain't no build errors in here. 39, line 39. Yep. Oh, else. Yeah. There's a build error. Oops. Okay. Takes the list, reduces down to 1. So then the next comment bit is zeros. So then it only takes zeros. Then third takes ones. Fourth takes ones. Oh, it didn't reduce. It didn't do the last iteration. So is that because right output lines, and then this is technically lines dot count. Okay, which should give us the right answer. No. We'll just put -1. That part doesn't matter. It does give us the right answer. So, which, I just realized is difficult for you all to see. Okay, so it does give us the right answer, 10111, which is what they were expecting us to get. So at this point, we know, what is this called? This is oxygen generator. All right, is 0. Convert to int. Basically, it's line dot first. What's that first? Base 2. Hey, O2 generator. That's actually exactly what we want. Okay. So if we rerun this, clear. Oxygen generator 23, that's what they got to. All right. So all right, so then CO2 scrubber is the same thing but in reverse. Let's rename this. Most common bit. Okay. We are. Now, I am not above just taking this and changing epsilon. So epsilon is going to be the least common bit. Now, what does it say here? Keep the number with the 0. Okay. So if there are equal numbers, we'll take the 0. Okay, that's how it should work. All right, let's assume reduce list to least common bit. Now, there's probably a much easier way to do this. I think we only really need to iterate, well, let's see. We don't need that now. Don't need that now. We'll copy that because we have to iterate through the list again. So let's reset our lines. So then this is CO2 generator. Or CO2 scrubber, right? Yeah. Scrubber. Okay, so let's take CO2 scrubber. Scrubber. And I need to do CO2 scrubber is equal to convert. Basically that. Okay. Okay. Iterates down the list. CO2 scrubber becomes something. We spit that out. Let's see if we get the same answer. Nope. All right, according to this, iteration 3. Iteration 3, we ran out of numbers because we're not doing a check in here to say if lines dot count is equal to 1, we should break out of the loop. Yeah. Same thing here. All right, so let's refresh. CO2 scrubber is 10. Is that what they got? Yes. All right, so then life support is O2 times CO2 scrubber. And I'm just going to leave what? Jeez. There we go. Okay. .NET run. 10. All right, so where did my O2 go? Oh, I never spat out O2, so let's go ahead and do O2 scrubber, O2 generator. And life support. All right, 2310 gets 230. They're expecting 230. The input's the same. So let's try this with bigger input. Clear. Let's run it. All right, life support 18. 7. Let's plug that in. That's the right answer. Another gold star. So I am done with day 3. So I hope that was beneficial to you. I'm not going to edit any of this out. We're going to keep in all the flaws and misdirections in my head. But I hope you have fun with Advent Code. Go give it a try for yourself, and I'll try to record it again tomorrow. With that, thank you, everyone. I will see you all next time.